Hello everyone, I am Alessandro Faz Garcia and I am a technical marketing engineer at NGINX. In this short NGINX CyberTech DoS demo, I am going to give you a brief review on how to deploy and train NGINX CyberTech DoS to secure your NGINX environment. NGINX CyberTech DoS is NGINX's latest security offering. It combines a highly performant Layer 7 proprietary algorithm based on user and service behavior analysis with NGINX's built-in security capabilities to predict and prevent DoS attacks. Furthermore, its container-first architecture enables it to be easily deployed in any microservices environment, as well as easily integrate in any CI/CD pipeline. Alright, so for time's sake, I've gone ahead and deployed NGINX Plus together with NGINX Protect DoS in a Kubernetes environment, set up a basic reverse proxy to running deployment of OWASP's Juice Shop application, which you can see running in the background right now, and set up a Kibana dashboard to parse and check that NGINX Protect DoS is working as intended. Now, if we look over my NGINX config, you can see that enabling NGINX CyberTech DoS within NGINX is as easy as setting the protect DoS enable directive to on. The other NGINX CyberTech DoS directives that I'm using in this config are optional, and if unset, will use the default values that I have explicitly included for extra clarity here. I do want to point out that I'm using NGINX CyberTech DoS's default policy, which enables using global rate mitigation during DoS attacks, as well as DoS mitigation using a signatures and bad actors attack detection algorithm. NGINX CyberTech DoS uses an adaptive algorithm behind the scenes, and since this is a fresh install, we do have to train it to recognize good healthy traffic before it's capable of effectively blocking against malicious DoS traffic. To do that, I'm going to switch to a different instance and run a script, good.sh, that generates healthy requests at a reasonable rate, and leave it running for around 10 minutes while the NGINX Protect DoS algorithm gets trained. But since this is a pre-recorded demo, let us magic those 10 minutes away. Okay. Let's say that the healthy login script has been running for over 10 minutes. This means that the NGINX CyberTech DoS algorithm should have been trained by now. We can double check this by looking at the Kibana dashboard, where we'll see that there's been some incoming traffic coming from 4 distinct IPs, and NGINX CyberTech DoS has been parsing those incoming requests, and has been parsing those incoming requests as healthy requests, which we can see by looking at the attack signatures and detected bad actors data graphs and seeing that there's no results found for either. So we can now test NGINX Protect DoS under action by launching a malicious DoS attack targeted towards the NGINX reverse proxy. NGINX Protect DoS should now be able to quickly differentiate the malicious from the healthy traffic, and appropriately drop any unwanted traffic before it negatively affects the proxy application's performance. Actions speak louder than words though. So let me show you it in action. Let me switch to a different instance where I have a script, bad.sh, that mocks a DoS attack. I am going to start it up. And if I go back to the Kibana dashboard and scroll down to the server stress level, I should be able to see how the DoS attack causes the Juice Shop application to be momentarily overwhelmed, with the server stress level momentarily reaching a value above 1 before it relatively quickly drops back to 0.5. Behind the scenes, upon detecting the DoS attack, NGINX CyberTech DoS enables its global rate limit mitigation policy to ensure that the application doesn't get overwhelmed, and thusly that good traffic is still capable of reaching, albeit at a slower rate than normal, the application. In the meantime, NGINX Protect DoS is creating dynamic signatures that match the malicious DoS traffic. And once these signatures have been created, NGINX Protect DoS will disable its global rate limit mitigation policy and proceed to block only malicious traffic. And indeed, right below the server stress level, which is almost back at 0.5, it's at 0.57 right now, you can see a list of any detected attack or bad actor signatures. In this case, as you can see, it's detected the source IPs for the DoS attack as being bad actors altogether. Finally, let me go to my OWASP GSHOP application and refresh it, just as the server stress level is pretty much there at 0.5, and see if the GSHOP application is still working as expected. And it is, even though the DoS attack is still going on in the background. Altogether, this lets us check that the NGINX Protect DoS proprietary algorithm has indeed worked as expected. Similarly, I've also got a slow post script that simulates a slow post attack. slowpost.sh. So let's go ahead and run it. Switch back to the Kibana dashboard and see how NGINX Protect DoS reacts against this type of attack. Once again, the server stress level should momentarily jump over 1, while the proprietary algorithm is creating some dynamic signatures, and then it should drop back again to 0.5 once NGINX Protect DoS has updated those dynamic signatures to block the incoming slow post attack. As you can see, it's now jumped up to 1.5. It's already recognizing the new source IP for the new bad actor, and the server stress level is already dropping back down. This time it's a little bit faster than with the DoS attack, since by virtue of blocking that DoS attack, NGINX Protect DoS has already improved its detection algorithms and its signatures. Let's back down to 0.64, and let's just give it a couple more seconds so that it reaches 0.5 again. Okay, it's a 0.53. I think it's good enough to now go back to our OWASP GSHOP application, refresh it, and see that it's working like it should. Refresh it a couple times just to test that it's not a one-off reload. And yeah, it's still working. Still working as it should. And with that being said, that's that for this short demo. I certainly hope you find it useful, and I certainly hope you don't hesitate to get in touch with us for further information on how NGINX can help you secure your applications against DoS attacks in real time.